In this short presentation, you will be introduced to the Pain Assessment Screening Tool and Outcomes Registry. The Pain Management Task Force recognized that PASTOR would be an ambitious project and that many pieces of the puzzle would have to come together before it could become a reality. Early on, it became apparent that by partnering with the National Institutes of Health and their PROMISE initiative, the puzzle pieces might come together much more quickly. So why NIH's PROMISE initiative? Simply because this initiative brings a very big puzzle piece to the table. In a period of 9 years, the National Institutes of Health will have spent over $80 million in the PROMISE initiative. So what is PROMISE? PROMISE stands for Patient Reported Outcomes Measurement Information System. Under the PROMISE umbrella are two very valuable resources for measuring patient-reported outcomes. First, PROMISE is a repository of many item banks. These item banks measure domains such as pain, physical function, and fatigue. An item bank is a large collection of items that measures a single domain. The second resource under the PROMISE umbrella is the Assessment Center, and I'll explain a little bit more about that later. Right now, let's start with the item bank part of PROMISE. For the next few moments, I'll use physical function as an example of what the PROMISE item banks are and how they can be used. There are several important characteristics of item banks. First, in aggregate, they should target the entire range of the outcome in the population of interest. So, if the people you are interested in range from low to high physical functioning, then you would want to make sure that the item bank that you developed would include items that measure across this entire range. Second, the items of the item bank are calibrated on a mathematical continuum. You might think of this as items being arranged mathematically by difficulty along a continuum that goes from low physical functioning to high physical functioning. We'll look at this more closely and hopefully that'll make more sense. Continuing with our example, it is easy to imagine that people could range substantially in levels of physical functioning. It's easy also to imagine that you could write items that target all these different levels of physical function. The process of calibration is simply aligning all of these items along the mathematical continuum that ranges from very low functioning to very high functioning. Once you have a calibrated item bank, new and creative opportunities open up for measuring patient-reported outcomes. One of those is computer adaptive testing. It's also known as CAT. CAT is a computer algorithm that tailors the administration of items to the individual. Here's how this works. If you know nothing about a respondent's level of physical functioning, the best guess you can make is that it's somewhere between low and high. Thus, the CAT algorithm begins by identifying an item that is of medium difficulty and then administering this item to the respondent. Let's suppose, however, that rather than having average physical function, our respondent is an elite athlete. If that is the case, she will answer this first item in a way that indicates she has higher function. Based on this first response, the CAT algorithm goes and searches a more difficult item to administer to our athlete, skipping over items that target low levels of functioning. The second item is then administered to our respondent. After obtaining a response to the second item, the CAT is able to make a better estimate of the respondent's physical function and, using a mathematical equation, is able to estimate her position in the measurement continuum. Every time she answers a new item, the estimate is updated, and the CAT algorithm goes again and searches the entire item bank for the most informative next item to administer. But what if, instead of being an athlete, our respondent has lower physical function? In this case, he will answer the first item in a way that indicates this lower level, and the CAT algorithm will go and seek out an item that targets lower physical function. The process of administering items, updating the estimate of the person's physical function, and then going in search of the most informative next item continues just as it did for our athlete respondent. Through this process, the CAT algorithm is able to place our very different persons on the same mathematical continuum. After only a couple of items have been administered, the precision of the estimate is low. But with more items, the CAT very quickly narrows in on the precise estimate of the person's level of physical functioning. This process continues until a specified number of items is reached. You might tell the CAT to administer 6 items to everyone, or until a specified level of precision is reached, or some combination of the two. These rules are called stopping rules. Now, this is a very technically sophisticated process compared to just handing a person a piece of paper with some questions on it. Therefore, it is fair to ask, why bother? Well, you can think of measurement efficiency as the amount of precision you get compared to the number of items that you have to administer. All other things being equal, the more items you administer, the more precise the measurement. What CAT does is maximize measurement efficiency by only asking the items that are most informative about each individual respondent. This tailored approach reduces the burden of responding, and it also leaves room for measuring additional domains that are important in understanding an outcome such as pain. There is one more advantage. PROMIS scores are reported on a T-score metric in which the mean is 50 and the standard deviation is 10. This mean is centered on a sample of people who mirror the U.S. population on important demographic variables. What this means is that a score of 50 approximates the U.S. mean. A score of 60 is a standard deviation above, 40 a standard deviation below. This unique anchoring to U.S. demographics gives the scores inherent meaning. This will be important later when we talk about score reports. Since this idea of anchoring to the metric of the U.S. population can be a little hard to wrap your head around, let me explain what we mean and also what we don't mean. In calibrating its responses, PROMIS administered measures of between 2 and 7 item banks to a total of more than 20,000 people. A subsample of this very large calibration sample was then taken that mirrored the U.S. population in age and also in gender, race, and ethnicity. A score of 50 then on the PROMIS measure is the average score of this representative subsample. The PROMIS reference sample was not a random sample of the U.S. general population and therefore does not mirror the U.S. population on all variables. For example, the reference sample is not matched on education or marital status. However, because it mirrors the population on many demographics that do affect outcomes, it provides a context for scores that is far more relevant than comparison to a sample of convenience. Next, let's talk about the other side of the PROMIS umbrella, the Assessment Center. The Assessment Center is a free online data collection tool that creates secure study, clinic, or registry-specific websites for capturing participant data. An important characteristic of this resource is its flexibility. The contents are completely customizable. The Pain Task Force spent a great deal of time and energy identifying the different outcomes that would be important to measure in a pain registry. Many of these were already part of the PROMIS portfolio. For example, PROMIS already included a measure of fatigue, pain interference, pain quality, depression, sleep-wake function, social function, and physical function. but the contents still needed to be pasteurized. For example, there were registration items and demographic items that were important to include. Screens for things like PTSD, suicide, substance abuse, and also the DVPRS pain scale. Here's an example of one of the measures that the participants will encounter. This is the Defense and Veterans Pain Rating Scale. As the participant's cursor goes past each of the numbers, the numerical option is highlighted to indicate where the choice is that is being selected. So what would come of all this data collecting? The Pain Management Task Force envisions a 2-page report that uses graphics, includes patient-specific information, shows outcomes over time, and highlights especially critical information. Let's take a look at some of the elements of the report. There's a graphical pain map that shows not only where it hurts, but also where it hurts the most. On the first page of the report would be the patient's personalized functional goals. These are entered by patients in their own words and are front and center to alert the clinician to what is most important to the patient. The Defense and Veterans Pain Rating Scale is included. It asks about pain intensity and pain's impact on important life domains. Not only are today's levels recorded, as you can see here by these markers, for example, this person's pain number was 8 at this particular recording, but also included is the direction of change. So the arrows and the equal sign indicate whether the level of pain or pain impact has stayed the same, increased, or decreased. Important clinical information is highlighted using graphic alerts that tell the clinician, for example, if the patient is experiencing suicide ideation or might be at risk for abuse or misuse of opioids. And finally, scores are reported across time. And because scores are anchored to a U.S. reference sample, they have inherent meaning. This particular graph has a lot of information in a single picture. It is evident that this person started with anger, depression, and anxiety levels that are about a standard deviation above the population mean compared to the U.S. reference population. And over time, those levels have been increasing. At the last assessment, those levels were more than 2 standard deviations above the mean of the reference sample. In summary, the PASTEUR-NIH partnership leverages the more than $80 million investment of NIH in the measurement of patient-reported outcomes. It creates a customizable tool that collects information that is important to the military in managing and tracking treatment and outcomes. And it is focused on the needs of warriors, their families, and the clinicians who serve them.